In July of 1994, humanity witnessed something extraordinary. A comet broken into dozens of pieces hurled itself toward Jupiter and struck the giant planet with unimaginable force. Each impact released the energy of hundreds of millions of atomic bombs. For 6 days, Jupiter was scarred by a series of colossal explosions, fireballs rising higher than Earth's diameter and temperatures hotter than the surface of the Sun. We might ask, what did this spectacle look like? What did it teach us about the solar system, and could something similar ever happen here on Earth? Today, let's revisit the story of Comet Shoemaker-Levy 9, the comet that forever left its mark on Jupiter, and see how this once-in-a-lifetime event changed the way we think about planetary collisions. Our story begins in 1993 at the Palomar Observatory in California. Astronomers Carolyn and Eugene Shoemaker, together with David Levy, were scanning the skies when they noticed something unusual, a comet unlike most others. Instead of circling the Sun, this comet had been captured by Jupiter's immense gravity. Shoemaker-Levy 9, as it came to be known, was not only massive but already fragmented. Jupiter's tidal forces had likely torn it apart during an earlier pass. Its orbit was extremely eccentric, almost hyperbolic, a sign that it had been pulled violently into Jupiter's grasp. Scientists soon realized the significance. The comet was large, with fragments up to 2 kilometers wide. Events of this scale were estimated to occur only once every 6,000 years. Almost immediately, astronomers suspected that Jupiter itself might be in danger, and then the calculations became precise. In July 1994, these fragments would collide directly with Jupiter. For the first time in human history, we would witness in real time a massive planetary collision. Anticipation grew across the scientific community. Telescopes around the world prepared for the moment. Yet there was a problem. The comet's trajectory meant the impacts would occur on the far side of Jupiter, hidden from Earth's direct view. Were we about to miss the greatest astronomical event of the century? Fortunately, luck was on our side. NASA's Galileo spacecraft launched in 1989, and en route to Jupiter was perfectly positioned to observe the strikes. The Ulysses probe, tasked with studying the Sun, also turned its instruments toward Jupiter. Even Voyager 2, billions of kilometers away, was instructed to listen for radio emissions. Together, these spacecraft formed an accidental team of witnesses. Thanks to them, humanity would not miss a single moment. On July 16, 1994, the first fragment struck. Galileo recorded a fireball hotter than 24,000 degrees Celsius. The plume shot 3,000 kilometers above the cloud tops, taller than the distance from London to Athens, or greater than Australia from north to south. For a planet as massive as Jupiter, this was an extraordinary sight. Within minutes, debris rained back down, igniting the atmosphere again. When Jupiter's rotation carried the impact site into view, Earth-based telescopes, including the Hubble Space Telescope, finally saw the enormous scar, darker and more prominent than even Jupiter's great red spot. And this was only the beginning. Over the next 6 days, 21 separate fragments bombarded Jupiter. Each one produced fireballs, shockwaves, and massive scars. The most devastating came on July 18th, when fragment G impacted. Its explosion was equivalent to 600 times the combined nuclear arsenal of Earth. The resulting mark stretched 1 Earth's width across. Shockwaves rippled through the atmosphere at 450 meters per second, a supersonic reminder of Jupiter's dynamic nature. For scientists, this was an event beyond anything they had ever studied, and for us, it was like watching a planetary-scale fireworks show. As spectacular as the explosions were, the aftermath proved just as valuable. For the first time, astronomers had a direct window into Jupiter's hidden layers. Spectroscopy revealed elements splashed upward by the impacts: sulfur, carbon, disulfide, iron, magnesium, even silicon. Most surprising of all was water, something scientists had not expected in such abundance. This discovery raised new questions. Where exactly is Jupiter's water-stored later missions like NASA's Juno would make this search one of their primary objectives. The impacts also allowed scientists to track how Jupiter's atmosphere circulated. By following the debris, they could map winds and currents deep below the cloud tops. It was as if Shoemaker-Levy 9 had peeled back a corner of Jupiter's veil, giving us a rare glimpse inside. But the story of Shoemaker-Levy 9 didn't end with Jupiter. The event forced us to confront a sobering reality. Planetary collisions were not just relics of the distant past. They could still happen today. If a comet of similar size were to strike Earth, the result would be catastrophic. Most life on our planet could be wiped out just as the dinosaurs perished 66 million years ago. This realization had a profound effect on society in the 1990s. It also gave birth to something new: planetary defense. Before 1994, the term barely existed. But after Shoemaker-Levy 9, NASA launched dedicated efforts to track near-Earth objects, aiming first to find 90% of all asteroids larger than 1 kilometre, and later extending to those over 140 metres. Thanks to this, we now know far more about the potential hazards around us than ever before. One intriguing idea emerged after the impacts. Could Jupiter be acting as Earth's shield? As the largest planet in the solar system, Jupiter's gravity attracts or deflects countless comets and asteroids. In fact, it may experience 2,000 to 8,000 times more impacts than Earth. Some scientists suggest that without Jupiter, catastrophic strikes on our planet would be far more common. This idea feeds into what is known as the rare Earth hypothesis, the argument that Earth's unique conditions, including Jupiter's protective presence, make complex life possible. Not everyone agrees, but it remains a fascinating possibility. Shoemaker-Levy 9 left scars on Jupiter that lasted for months, but it also left a lasting mark on us. It showed that our solar system is still dynamic, still violent, and still full of surprises. It advanced science, sparked new missions, and inspired planetary defense efforts that continue today. Above all, it treated us to one of the most spectacular cosmic events ever witnessed. Perhaps one day we'll see something even larger. Hopefully, it will remain far from Earth. Until then, we can look back at 1994 as the year we watched Jupiter absorb the biggest planetary explosion in recorded history.